Welcome to Lesson 10. This is the second part of our lesson. We are looking today at weather measuring instruments. No fancy stuff today, we're just getting right down to business. Our objective for today is for you to be able to identify the various weather instruments and how they measure weather. So we'll be doing a lab with this as well, but for today we want to make sure that you have a basic understanding of what the weather instruments are and how they're used. A thermometer is something you're all familiar with, I'm sure. It's an instrument that measures the air temperature, and if you notice our picture here, you have the option of Fahrenheit and of Celsius. Now, normally in science we will use Celsius, but because most of our weather is reported in Fahrenheit, for our purposes today and for this unit, we'll be using Fahrenheit for our recording of the weather temperature. A change in temperature is a predictor of a possible weather change, so you have to keep that in mind. A barometer is the second instrument that we'll be using. It's basically an instrument that measures air pressure, and when we see a change in air pressure, it's usually indicating or indicates when an air mass is moving through an area. And then when that barometric pressure is rising, a fair weather air mass is moving into the area, because remember that the higher the pressure is, usually we have fair weather. If the air pressure is dropping, a storm may be approaching. So the lower pressure moving in usually indicates a weather change. We also have weather instruments that measure specific things. For example, we have two specific weather instruments that will measure air movement. An anemometer is a weather instrument that measures the air speed, so our wind speed. And we also have a wind vane, and that is an instrument that shows the direction of the weather. So if you look at our example here, this is our anemometer, and it basically rotates with the wind. And when you count those rotations, it will tell you how fast the wind is moving. And this is basically going to change with the wind speed or the wind direction, and it will point in the direction that the wind is blowing. We also have instruments that will measure moisture, okay? So that we have a rain gauge. It's a weather instrument that measures the amount of precipitation, snow or rain typically, that has fallen. So all it really does is collects it for us, and then you can measure what type of or how much rain or snow or precipitation in general has fallen. Now, lastly, we have a sling psychrometer. This is an instrument that basically tells us about the relative humidity in the air, so how much moisture is in the air. It uses a dry bulb, which means that it's basically a thermometer that has nothing on it, and then a wet bulb. And that wet bulb, we actually put something on the end of that thermometer that is wet. The warmer the air temperature the warmer the air temperature is, the more moisture it can hold. So when we calculate this, really what we do is we spin that sling psychrometer for about a minute. One of the wet bulb will actually have some moisture that we drop on it. The dry bulb will not. So as you spin it, that moisture will evaporate, and because of that, it will bring the temperature down. So what we wanted to look at is the difference between the two temperatures. So when we want to calculate it, we've got the directions over there to the right for you. You're going to take the dry bulb temperature and subtract the wet bulb temperature. The wet bulb should be cooler than the dry bulb. That's going to give you the difference between the two temperatures. And then there's a chart that we use that we'll talk about a little bit more in class. And that chart will help you determine the percent relative humidity when you find the dry bulb temperature and then the differences. So when that relative humidity is 100%, there's going to be some form of precipitation in the form of usually rain or snow falling. Now, if you're continuing on with us today and doing the lab, there are going to be different stations for you to go to today. First of all, we're going to be looking at the temperature, and we're going to use the thermometer for that. Now, you're going to be able to use the dry bulb thermometer of your sling psychrometer, lots of words, in order to take this temperature. So when you read it, you'll read the temperature both in Celsius and in Fahrenheit. You'll also have a barometer out there, and so we've set the barometer at 8 a.m., and then you'll see if it's different during the time of day that you are taking the pressure. And then based on those two barometric pressure readings, what type of weather is moving into the area. If the air pressure is going up, then we're having a high pressure moving in, so things should start to settle down and we should have calm weather. If that air pressure is going down, then we're going to notice some change in weather coming our way. We also will have a wind vane direction, so you should be able to look at the wind vane and see which way the wind is blowing. Sometimes we look at a flag or something that's blowing in the wind to tell us the same thing. And then you're also going to look at our rain gauge. It will tell us the amount of rain or snow that's fallen. Now, we have some precipitation today, but it's very, very minimal, so we may not see much of a difference there. Now, lastly, you're going to be doing the other two weather instruments and weather measurements, and these are going to take a little bit of calculation on your part. The anemometer, the wind speed, you're going to count the number of revolutions in 1 minute. So there's one cup on that anemometer that is a different color, and so as it spins, you're going to count the number of times that passes a certain point. Then you're going to calculate the distance traveled in 1 minute. So you're going to use the following equations to do that. So we're looking at 2 pi r really is what we're going to be using. So you take 2 times pi, which is 3.142, times the radius, which is 4 inches in our anemometers here in class. Then you'll multiply that times the revolutions. So how many times did it go around? And then that'll tell us the inches, how many inches it's traveled. But we really want to have that in feet so we can start to get towards miles per hour. So then you'll divide it by 12, and so that's going to give you the number of feet that has been that's been traveled during the time. Then you're going to take that number of feet from step 2 and multiply it by 60, because this is only a minute that it's traveled that distance. So we want to know in an hour how far would it actually travel, and that's going to give you the number of feet it would travel in 1 hour. And then because a mile is 5,280 feet, we will take the number that we got in number 3 and divide it by 5,280 feet, so that it will give us how much wind we see, what the miles per hour is of the wind. Okay, that's the first one. Now, the psychrometer is calculating the percent humidity. So you're going to put 3 drops of water on the thermometer that has the cloth on the bulb. That's your wet thermometer. You're going to twirl the psychrometer for a minute. So you'll probably need something to time with. So maybe one of you can have a Chromebook out timing. So you're going to time it for 1 minute. Then you'll record the 2 temperatures below. And you're going to calculate the relative, it should not be relativer, sorry, humidity, when you get back inside with the chart that was supplied by me. So you'll do the dry bulb temperature, the wet bulb temperature. You're going to subtract the wet bulb from the dry bulb, and then you're going to use that chart, and it will tell you how much humidity or how much moisture is in the air. And that should do it for today. We will see you soon.